Okay, so the final question of the covalent bonding section, it's going to ask us to look at advantages and disadvantages of the various different ways we can represent covalent molecules specifically. It's going to ask us to look at displayed formula, dot cross diagrams, and obviously 3D model. Now, if we take the methane molecule that we looked at earlier, then we have a central carbon bonded to 4 hydrogens. And in a displayed formula, we have this stick diagram, which represents the shared pair of electrons, as we've already seen. And this is good because it simplifies the molecule quite easily. You can easily see that carbon is bonded to 4 other hydrogens, and it gives you just a little bit of information about what is bonded to what. However, what it doesn't do, as a dot cross diagram will do, is if we just quickly have a try and go at this one, is that the dot cross diagram gives you more information as to where the electrons have all come from. So it gives you essentially the same type of information as the displayed formula diagram, but gives you more information in the sense of electronic arrangement information, in that it's a shared pair of electrons, which electron came from which, etc., etc. So it kind of takes a displayed formula and makes it a little bit more complicated. Three-dimensional model for methane, however, takes a kind of displayed formula. It doesn't show you where the electrons are, but gives you, as the name suggests, more of a three-dimensional representation. And this allows you to get kind of a three-dimensional representation of what a molecule actually looks like in three-dimensional space. Now, in order to try and visualize this, this is the hydrogens kind of at the base of a triangle here, with the hydrogens on top, kind of giving you a pyramid type shape with a carbon in the center. It's called a tetrahedral shape in 3 dimensions. Now, so that's obviously the advantages of the various different situations, but kind of analogous to that, you can fairly quickly see what the downsides of these will be. A three-dimensional molecule, a three-dimensional model of a molecule, as well as a dot cross diagram, will both get very complicated very quickly. If you've got a large molecule with, say, 20, 30 atoms, a three-dimensional molecule is going to get quite difficult. And a dot cross diagram could get very difficult as well when you've got dots and crosses and overlaps, and some might be double bonds, etc. And it's going to get very complicated very quickly. But the advantages sometimes of having that knowledge of where those electrons have come from is then lost in a displayed formula, and is obviously one of the downsides of a displayed formula, in that it allows you a very simplistic way to look at a molecule, but the simplicity of that, you lose some of the actual analytical information that you might get from that. So moving on to 4.2, then it's asking us which, though, of the representations, because you might have to choose one at a time, would be suitable for the structure of a large polymer. And a large polymer is something which could have thousands of carbon atoms within it. And I think for that one, the obvious solution is the displayed formula, because to give three-dimensional representation of something with thousands of carbon atoms and even more thousands of hydrogen atoms bonded in that molecule is going to be quite difficult to represent in 3 dimensions. And to draw a dot cross diagram of that is going to take even longer. So a displayed formula simplifies the molecule down. It shows you how the connections are made between the carbons and how the connections are made between the hydrogens, assuming it's a hydrocarbon polymer. But a displayed formula, especially, key point being it's a large polymer, displayed formula is definitely better. Dot cross diagram for small molecules like methane, fine. But displayed formula when the molecule gets big.